Question 1. Predict the yearly salary of an engineer who has a 3.5 undergraduate GPA and 10 years of experience. So predict the yearly salary. So y hat we have to find. Y hat for x1 GPA 3.5, years of experience 10. So A plus B times 3.5 plus B1 times 3.5 plus B2 times 10 is equal to. You have to compute this way. So in calculator, four 0 1 2.80219. This is not yet correct. 4012.80219. This is A plus B1 18189 18189 times x1. x1 is 3.5 plus B2 2538.87237 times your experience x2 10 years. All correct, right? A plus B1 x1 plus B2 x2 is equal to, so $93, yearly salary dollars, $93,063. Interpret the coefficient of determination. So what is the value of R square? R square is 83.8378. This is equal to 83.78 divided by 100. This is 83.78%. So R square is SSR divided by SST. So SSR is this one, SST is this one. Okay, interpretation. The regression model explains 83.78% of total variation in Y. Total variation in Y is SST. The error explained is removed is SSR. So the regression model explains 83.78% of the variation in salary Y. Question number 3. At 5% level of significance, alpha is 0.05. You use 0.05. You use this value when reading critical value. That's a hypothesis to determine whether the regression model is significant. The model is this equation. Y hat is equal to A plus B1 x1 plus B2 x2. This model is significant. That means another equation which will be valid for the whole population, alpha plus beta 1 x1 plus beta 2 x2. There is a non-trivial equation of this type for the whole population. That equation will be non-trivial if beta 1 and either beta 1 or beta 2 is not 0. If both are 0, the equation will be trivial, not significant. Okay, so HO is both beta 1, beta 2 are 0. That means there is no significant equation, no significant model of the type. So HA, if you write short, symbolic form, beta 1 is not 0 or beta 2 is not 0, or you can write at least one of beta 1 and beta 2 is not 0, non-zero. Okay, or you can write in what form the regression model is not significant. There is a yes. What is the critical value? So you have to recall how to read what table? F table, degrees of freedom, numerator k is here 1, 2, k is 2, and denominator is m minus k minus 1. So n is 20 here, n is 20, k is 2, 1, this one is for y, 217. So in F table, column 2, row 17, and the table you have to read at the table for 0.05. So you go to F table. This table is for alpha 0.05. The regression region is on the right. F values are always positive, never negative. And row 2, degrees of freedom for numerator, column 17. So 3.57, 59, 3.59. 3.59, the rejection region is on the right of 3.59. The critical value is 3.59. The rejection region is on the right. What is the value of the test statistic? The table is F, so F statistic, this is the F statistic, this is MSR, regression model, MSR divided by MSE error, MSR divided by MSE. This is called F statistic, 43.92. Its p-value is smaller than 0.0001. So the statistic is 43.92. P-value is smaller than 0.0001. Okay. So p-value is smaller than alpha 0.05, 0.05. Therefore, reject HO. P-value smaller than alpha, reject HO. So what do you write? HO is false. HA is true. So you write formally. The null hypothesis is rejected, and the conclusion would be that the regression model is significant. Okay, only this. Or you can write at least one of the regression slopes is non-zero. You can also write this way also. Next, at 5% level of significance, alpha 0.05, test a hypothesis to determine whether GPA is a significant explanatory variable. That means for us in the table x1. x1 explains y, for some extent. That means in the equation, in this equation, beta 1 is not 0. So beta 1 is not 0, HA, beta 1 0, HO. Beta 1 is not 0. If beta 1 is not 0, then in this equation, if you change x1 value, y hat will change also. You will see effect of x1 on y, effect of GPA on salary. Okay, that means GPA explains salary level, more or less. So you write this way, HOHA. What are critical values? This is a two-tailed test. This is t-test. You must remember. You must read t, two-tail, and in the middle 0.95 at the tails. Two-tail area must be 0.05, alpha. So you go to t table and read, plus and minus two values. In reading t table, degrees of freedom is n minus number of variables, kx, 1y. In this case, n is 20, k is 2, therefore 17. Degrees of freedom, 17. Now, our two-tailed test, alpha 0.05, this column number 3. Degrees of freedom, row number 17. So 2.110, 2.110. So 2.110. The value of the test statistic here, x1 GPA, this row, t statistic 4.53, p value 0.0003. So 4.53, 0.0003. So this is also smaller than alpha 0.05. 0.05. Therefore, reject HO. HO is false. HA is true. The null hypothesis is rejected, and the conclusion would be that HA, this is HA, HA is correct. That means beta 1 is not 0, x1 is significant. So you write the conclusion would be that GPA is a significant. Significant means important. Explanatory variable. That's it. Now the last question. Which independent variables are significant at 5% level? x1, GPA, x2, years of experience. GPA is significant, right? Already by 4y. Question number 4. You can do the same here also. Beta 2, 0 or not. Beta 2, 0 or HA, beta 2, not 0. Critical value the same. And test statistic 4y, 43 for years of experience. So test statistic 4y, 43. P value, as you see, 0.0004. 0.0004. Smaller than alpha, 0.05. Reject HO, therefore Years of experience is also a significant explanatory variable. Therefore, you write here years of experience like this.